Well, if I didn't make a mistake, I got my tangent line. I don't, it definitely seems possible that there's a slope of 1/2 there. Let's see. Yeah, I guess so. Tough problem. Yes. Where are you at? 5? Yep. Uh, so yeah, in line 5, I factored out the y prime, right? The algebra at this point is hideous. There's no way around it. Got to do it. You got to practice enough that you'll make mistakes at home instead of making them on the quiz or on the test. Uh, there was a y prime on both sides, but then I moved all my y prime terms to the left, right? And I moved my non-y prime terms to the right. There's no point to even any part of life, but we're trying to find the slope at that. We're trying to find that tangent line. Yeah, of the one exactly pi over 2 comma pi over 4. Yes. Oh, I get it. What's the point? Yep. Nice. Why don't we take a little break? Let's come back at 10 of 2. So there's our cardioid. This is number 25. Is that right? Yeah, number 25 and 5.5. Very, very cool that Desmos can do this. Our calculators cannot, right? So this one you cannot solve for y. It's just too much of a mess. So let's see what happens when we take our derivatives and see if we can get a decent derivative. So I'm doing d dx of x squared plus y squared should be d dx of this other side. So when we take the derivative of x squared, it's easy, right? 2x. What's the inside there, though? What's the inside? What's the inside function there? If it's x squared, what's the inside function? X, and the derivative of x is 1. So I'm doing the chain rule there. I did the 2x for the derivative of the outside function times 1 for the derivative of the inside function. For the y squared, though, I get 2y prime, right? Because the derivative of y is not 1. The derivative of y is y prime. That's just implicit. On the other side, I get 4x plus 4y prime minus 1. I'm sorry. Silly Robert. 2 times 2x squared, right? 2y squared minus x now times a 4x plus 4y y prime minus 1. So strange, right? Just looking at this, what's the inside function? Y. What's the derivative of y? Y prime. But the outside function is something squared, right? Or 2 times something squared, right? So there's where I get the 4y from, and the y prime is from the derivative of the inside. This thing is pretty damn nasty, but I do know every x is 0, right? They gave us the point 0, 1/2. So I can simply cross out my x terms to get my slope. If I simplify that, I get 2y y prime equals 2 times 2y squared times 4y y prime minus 1. So I just let all my x's be 0. My y's are 1/2. So I get 2 times 1/2 times y prime equals 2 times 1/2 squared times, 4 times a 1/2 times a y prime minus 1. So this way, everything kind of will cancel out here. So it looks like I get y prime equals 2y prime minus 1. So y prime is 1. The slope is 1. Oh yeah, you can already see it, right? Y equals x plus 1/2. There it is. In that case, it's not that easy to solve for y prime. Is it possible? Yes, but it's such a mess. It is really such a mess. I guess I could kind of see myself solving for y prime here. I'd have to distribute these guys and then get my y prime term all to one side. But it's really, really nasty. Yeah. You need me to zoom anywhere? Say again? Yep. 1 is the slope. Yep, and the point was 0, 1/2, so I had the b value. I let all of the y's be 1/2. Yeah, so these canceled, so I just got y prime. Yep. 2 times 2 and 1/2 squared is 1. So that's all 1. 4 times a half, there's the 2y prime minus 1. That's all that survived. Say it again? Yeah, all of this stuff is 1. Two times 2. Yeah, it's okay. Well, if it's not a b value, you gotta use our friend y minus y1 equals m times x minus x1, right? But they gave me a b value, so I could just go right into mx plus b. All right, here we go. Next section. You got lots of work to do. Remember what I told you. You needed to be caught up to me because the chain rules where it starts to get tough, right? So hopefully you got all the product rule stuff done, quotient rule stuff, trig, right? You're working on all of that stuff. We're doing inverse trigs today. So it's a tough section if you haven't been in pre-cal in a while. Please read section 5.6 in its entirety. So, sorry, 3.6. So 3.6 is inverse trig functions. So if you don't remember your trigs, you certainly don't remember your inverse trigs. So it's a good idea for you to go read this section, go back and review your inverse trigs section from pre-cal. We would like, so this is 3.6 inverse trigs. So I'd like to find the derivative of tangent. Sorry, I'd like to find the derivative of arctangent. The inverse trig, right? But I don't know how. But now that I'm implicit, I can use the inverse function here, which is what function? What's the inverse function of arctan? Tangent, yeah. So I can just use the inverse function. So tangent of y equals the tangent of the arctan of x. What happens on the right there? What does it become? No. Tangent of arctan of x. What is it? It's just x. They're inverse functions, right? So now I know tangent of y is equal to x, and I can do my derivative, right? Because I know how to take a derivative of tangent of y. By the way, I've got a triangle at this point, right? Angle y, height of x, base of 1, other side is square root of 1 plus x squared. So help me take a derivative now. What's the derivative of the left-hand side? Is 1. Derivative of tangent is secant squared of y times y prime. Nice. So I get y prime is 1 over secant squared of y, or just cosine squared, right? And then I can go back to my triangle and I get y prime is what? What's the cosine? Nice. So final answer, that's a square, sorry. Final answer is 1 over 1 plus x squared. So we have two versions of our arctan now we need for our formula sheet. Cos is adjacent over hypotenuse. If y is the arctan of x, y prime is 1 over 1 plus x squared. Better yet, if y is the arctan of u, y prime is u prime over 1 plus u squared. We want to think of everything now with our chain rule, right? We want to think of everything in terms of our chain rule, all of our functions with some unknown function inside. Yeah. That's right. Yeah, so on this particular one, I already know, so there's something special about um, derivatives and inverse functions. So since I already knew how to take a derivative of tangent, all I had to do was turn my function into tangent, right? And then work on it explicitly. There wasn't another way yet to do this derivative. In the process of how we're learning calculus, we came to a function, we didn't know how to deal with it, but we could turn it into a function that we did know how to deal with. Let's do, yeah. Yeah, exactly. Inverse trig, properties of inverse trigs. Arctan. Yeah. Because we couldn't solve it for y. This one, we had it solved for y, but we don't know what to do. I don't know what to do with arctan, but I do know what to do with tangent. So I turned it into a tangent function. In 3.5, I couldn't solve for y, so I had to use implicit. Mm-hmm. So we just did a derivative there, right? First I drew the triangle, and then I took a derivative. So derivative of x is 1, derivative of tangent is secant squared, and then the derivative of y prime. That is chain rule, yep. Yes, I will say this, we use the chain rule all the time, right? Even if I had an x inside, right? So y prime is what? Negative sine of x times x prime, right? But that's just 1. So right, we don't have to bother doing it times by 1. We don't have to. But we're always doing the chain rule. From now on, always, always, always. All right, let's do a problem here. I like y equals the arctan of x squared. So we have our formula, right? We know that y prime is u prime over 1 plus u squared. So all I really have to do is figure out u, x squared. U prime is 2x, and u squared is x to the 4th. So once I have all of those pieces, I know instantly that y prime is 2x over 1 plus x to the 4th. Yep. Yep. Let's do arc sine. Yep. Yeah, it's so you could say what y is the arctan of x. You could say y is the uh, inverse tan of x. So that you pronounce that as not power 1, -1, but inverse tangent. Arctan. No. I don't like this notation as much because of that students often will think of that as a reciprocal and it's not. So that is actually read the inverse tangent function. Y is the inverse tangent of x. Let's do arc sine. What's that? Say it again. No, but you think in tangent. So if I gave you the arctan of 1, you would have to think, well, what angle for tangent gives me 1? Pi over 4. So you don't think in terms of arctans, you think in terms of tans. Okay. Yep. Let's do y equals the arc sine of x. Well, I don't know what to do with this, but I do know I have an inverse trig, right? I have an inverse trig, and my inverse trig says that x has got to be the sine of y. Everyone agree with that? I just know inverse trigs, so I don't know how to deal with arc sine, right? I'm trying to find the derivative of arc sine. I don't know how to do it, but I do know how to do a derivative of sine. So I turn this thing into a sine function, right? So do you see what I did from step 1 to step 2? I took the sine of both sides. What happens to sine of arc sine? They cancel, they're inverse functions. So now I have a triangle. It's a right triangle with an angle of y, and I know the opposite of over adjacent is x over 1, and the remaining side by Pythagorean theorem is 1 minus x squared, square root of that. I'm just doing the Pythagorean theorem there, right? You agree? Good, let's take derivatives. So on the left side, I get 1. On the right side, I get cos of y times y prime. So y prime is simply 1 over the cos of y, or the secant of y. And I can get the secant of y from my triangle right there. So I know y prime is 1 over square roots of 1 minus x squared. So if y is the arc sine of u, yep, y prime is u prime over square roots of 1 minus u squared. I typically don't ask anything but arctan and arc sine. It turns out that if y is arc cosine, I get y prime is the It's just the opposite of arcsine. Let's do a problem from the book. Anything look interesting there? One through 15 is all from pre-cal. Let's do 24. That's pretty hideous. This is 5.6, number 24. We're trying to find the derivative of y equals the arctan of x minus square roots of 1 plus x squared. Yuck. Well, I have this formula written down. I know if y is the arctan of u, that y prime is u prime over 1 plus u squared. So I simply, these are so easy now that I have this formula, just got to do the algebra. So u is the inside, x minus square roots of 1 plus x squared. Obviously, oh, that's u, sorry. It's obvious that u squared is that squared, and I don't know if I have to do anything with it yet, so I will wait. But I need u prime, right? Yeah, yep. So that's what I got so far. Everybody okay here? Derivative of x is 1, right? Derivative of x is 1 minus the derivative of square root. There's 1 over 2 square roots times the derivative of the inside. No, u squared I left alone. U squared is, sorry. This is u to u prime is here, right? But still, derivative of x. Okay, I'm trying to find my derivative. I have my formula. So I have 1 minus x over square roots of 1 plus x squared. There's u prime over 1 plus this junk. Ugh. And I'm definitely not going to see that in the book. So I'm going to try and simplify this a little bit. Horrible. Damn it. I was hoping something would go away. Huh? I don't think it's going to simplify, so I don't know what to do. I wish I didn't pick the problem. It's just ugly. Where is that? Yeah, so I foiled this out, right? I foiled this piece out. Yeah, yeah, 1 plus 1, x squared plus x squared. Yeah. Which one? Yeah, but I'm taking a negative times a negative. Yeah, that's about as good as it gets. Pretty ugly, but it's all right. So you've got 2 new sections to do. I'm sure you're still doing chain rule, right? You've got to make sure you're working on old tests. Yes? Good, let's take a quiz. Quotient rule, product rule.